Hi there. I've been teaching high school students machine learning for a few years now. This is my main site, Rocksetta. And what I'd like to do today is take us through Edge Impulse's method of doing, I'm going to do accelerometer, but they can also do images and sound. And when I've been teaching machine learning, I've got lots of examples using JavaScript, TensorFlow.js. And for simple stuff, that's great, but eventually you get into harder things that have a time component. So acceleration, if I'm going to, in our case, we're doing letters. So if I'm going to do a W, it's not just one concept, it's the acceleration that's changing over time. And what Edge Impulse has done is taken this quite difficult thing to do and make it reasonably simple. So I've got a blog here on a GitHub site, and I'm just going to go through the blog, but the blog doesn't really get across how to do some of this stuff. So if you go to Edge Impulse and log in, it automatically goes to my login. So a couple of things here. One is when you click on your name, you can pull that down to create new project. I have this project I'm working with my students, and Edge Impulse has allowed us the equivalent of a paid account so we can have collaborators. And what you would do there is you would click here. A regular account won't allow you to add collaborators, but the paid account does. And you just enter their email or their Edge Impulse ID, and they get to collaborate with you. Collaboration is really cool because you can train your models in parallel. Now, one thing I've gotten used to doing, we load these models onto Arduino, and in Arduino, when you actually go to load them, they are entered at the bottom. Let's go down here. There's words. But when I load a new one, I'm not quite sure what it is. And this is what we're doing. We're just doing the accelerometer one, and my class eventually will manipulate this to what we want. So what I've been doing is I've been changing the name, and in this case adding W-3, so that when I install it on an Arduino, I know it's the updated version. Anyway, let's go through this. Our guiding is going to be this blog, and I'm not actually going to read it. I'm just going to go from the pictures here. So the first thing is the dashboard. And what you need to realize is these three lines up here call for a menu, and there are a bunch of things that we're going to be working with. First, we're going to connect to devices. Then we're going to collect a bunch of data. Then we're going to design our impulse. Impulse is kind of the same thing as a neural network model, but we call them impulses here. Then you can live classify, and this is what's kind of interesting. Instead of using your Arduino, which you can use your Arduino to grab the samples and load the final result, we're going to use our cell phone, which has an accelerometer on it. Somehow Edge Impulse has allowed access to that. Now, you can, once you've finished, you can live classify. And versioning. Versioning is kind of useful because say I wanted to work with my class with some images, then I can save that version of this project, delete everything, work on something else, which is what I've done here. We're now working on acceleration. And the last one is deployment. By the way, when you go to your dashboard, when you first go there, it's not going to have some stuff here. These are all the saved. This is our data saved in MPY file format. And then here are our model. And this one, very interesting, it saves you a TensorFlow saved Keras model, which you could load onto other platforms. So that by itself is useful. Here we have the ability to delete the project, which I'm not going to do because this is the only project I'm allowed to share with people. But here deleting all the data is really quite useful for just starting again. So back to our blog, create new project. And so this is just talking about the dashboard. and the saving stuff. Now, we want to go into devices. So let's go on to devices. And if you were working with your Nano, which a few of our students have a Nano, they would connect their Nano 33 BLE Sense. But most of our students just have mobile phones. And so if you see here on my mobile phone, which I'm just going to clear that so I can get in there. And don't know why it's not working. Oh, I lost part of the edge. Let's shrink this down a bit. There we go. They're really fast. There we go. Let me show you the screen. There you go. Okay. And there it is. So it says my device is there, and I just click off those screens. So now my device is one of these. If I shrink that down, you don't need to see me. It is KGD. Anyway, you would look up there. There are a whole bunch of devices. They're just random names. And this is kind of the concept of my small group, after-school group from Gearbots, is loading up devices. Okay, so the next thing we're going to do is data acquisition. It just occurred to me I don't really want to add stuff to this. Oh, I guess well, whatever. Let's add some things. So, what do we got here? We are in data collection, data acquisition, and we've got training and test data. Now, the test data, the student who has the Nano 33 BLE is going to work on the test data area and has already uploaded stuff. We're going to work on the training data, and my students have already uploaded. The labels have been still, meaning the Nano 33 or the cell phone is still. Erase, which is we're planning on just going like that if you want to erase the last letter. And then we've got several, and this little balancing device over here shows you what we've got. We've got several D's, several O's, several R's, several S's. Now, with data collection, we could upload something else. So that's my phone. They have labeled it as that. Still, ooh, that's going to be easy to do. Let's not do still. Let's do erase. Erase. Accelerometer. And 3, I had to change that to 3 seconds. And the frequency, there is no other frequency. But there were other things here. There's microphone and camera. And if you look at this, it's already set for collecting images. But what I'm going to do is put this here, and we're going to start. Now, this was really easy to do. So we're going to start the erase and scan. There's the data, and that's all I wanted. Okay, so now we can go have a look at that data. There it is, erase, 3 seconds, and have a look at it. That's not too bad. Notice the z-axis, which has the 10 meters per second squared. That's the acceleration due to gravity. That one's kind of messed up a little bit, but not too bad. It's moving, and that's what we're trying to do. So my students have entered a whole bunch, 14 pages of this stuff. And let's go back to the blog, because I've just kind of proved how we can do this. So on the blog, we've got devices. That's what my phone's doing. Data acquisition. And over here, I'm showing you, write the label. Make sure you got the right phone. Make sure it's accelerometer, 3 seconds. You could pull down to find other, and start sampling. So let's go down the blog a little bit more. I already explained this, the whole balancing of your data collection. Really nice to have that. And moving down a little bit more. Test and training data, you can also enter your test data, or you can have it automatically set that. Forgotten where the actual thing is. And then, what's this one about? Data acquisition. It's probably mentioning, oh, we had an issue. some of the cell phones, and I think we figured it out last night, Apple cell phones have the acceleration as -10 when your phone is face up. And so people with the Apple cell phones had to turn their phone this way to do their analysis. That was actually really fun for the students to figure that out. The other thing is, we're lining up the Nano with the USB facing towards us. Well, for that to work on the Android phone, we originally were doing analysis like this, and it wasn't making sense. You could tell by the graph. We eventually found out that the phone turned like this now works the way we were thinking, this being the X direction, this being the Y, and Z being up and down. So that, seeing the data, really helped check whether our test data was making sense with our other data. Later on this blog, we had a funny situation where we had entered unknown and unknowns with an S. So I explained it, and one of the kids found this fancy little select multiple devices and changed every label to the letter O. And there was a bit of a shock kind of horror moment, but we found out that all the ones were properly labeled when they first got data. So we went through and relabeled things. So this ability to select multiple items is awesome, but like lots of awesome things, it has lots of power to mess things up really bad. So now we're going to go build our impulse because we have enough data. So once again, we're always flipping back and forth from this. We're going to go to impulse design. And right now, I don't think I'm going to actually build it because this one's actually kind of working. Couple of settings here. That was the 3 seconds. And we just reduced this down to 100 milliseconds. This is a window that's going through the data, shifting across to get better information. We also tried getting rid of the Z-axis, but then our Arduino program is expecting 3 acceleration axes, so then it didn't work. You can add more networks. You know, you can add more of anything here. It tells you we're just using the defaults. Once again, you can add more stuff there. And then what's kind of nice is it tells you what it's looking for. So we're looking for the letters D, O, R, S, still, W, erase, and unknown. And so you would save that. Then going up here, spectral features. One little gotcha here is it gives you the parameters so you can go through your data and information here, and there's lots of feedback information. But you have to go to generate features, which the button's a little funny, before you can actually click on generate the features. Now what's nice, as I said, this one's already pre-built at the moment. And the generate features is really fast. What's really cool here is this graph. Okay, because that's showing you, the coloring here is showing you how your model is separating stuff. So D is blue, D's right in the middle there. Green is R, R is right there. And remember, we're drawing these out. So that's an R, this is an O. And we're trying to get our Arduino to write letters. So eventually we could write words. The erase one is over here. So that's really cool once you have done your generate features, which I'm not going to do right now. It's really quick. The last step is the Nano Classifier. This one's a little bit slow. The default here was set to 10. And while it's classified, oh, and you can change these things around, add more stuff. You can, I can't remember exactly how right now, get into the actual neural network design. And then when you click start, it gives a bunch of information. And you can watch the loss. Loss gives you a bit of a sense of how it's training. And we found out, when I tried 300, and the loss went from 2.5 down to 0.9. It was actually declining, which is a good thing. So I bumped up my cycles. And I think, yes, it gives us a confusion matrix. And the first time we did this, we got terrible values. Let me see if I can shrink there. If I mouse over this, 75% accuracy. It's this green line in the middle you want to look at. And we didn't even have green dots here. We had a whole bunch of red dots. So this is looking better. Definitely O is not as good as D, but we will have to see when we're actually making them. So let's go back to the blog, see what's being talked about on the blog. That's just going through. Oh, I do mentioning versioning. Versioning is kind of cool because when I click there, it's like forking a GitHub site. When I click there, I myself, not my students, can now fork where that project was at that time. And if I had a paid account, then I could reassign people to collaborate with. We always are only using our present impulse. And so here it's talking about what I just went through, creating the impulse, then spectral features, and then the neural network, and here's the original. It's hard to see on the screen, but my original confusion matrix was just terrible. And our data was pretty terrible. And our data isn't perfect yet. So the next step is deployment and testing. I'm going to deploy it, throw it on the Arduino, and then show you some live classifications. So let's go back here. Let's go in here. Let's go down. And I must admit, this is a long video, but what this is doing is making it grade 9 easy to make a neural network, a machine learning, deep learning model, and load it up on a Nano 33. I think they're like $30 Arduinos. Now here, we could mess around with that. We could mess around with this, but I'm just going with a basic default. Once it's working, then sure, you could probably, so that was it. It's saving it. It looks like it's in my downloads. So sure, I'm saving it. And that's probably already saved. So let's jump over to our Nano. I already have the board set up. In this case, it's already breathing. Is it breathing? Let's double click it. There we go. You see the orange? It's breathing orange in this case. And the port is correctly set up. No, it isn't. Now it's correctly set up. And it's saying it's the Nano 33. I already have the sketch for accelerometer, the library for accelerometer. The only thing I don't have is the zipped file of my impulse, which I know got saved in the downloads folder. And let's go in there. Why am I not going in there? I don't think that worked. So include zip file. I want to get into my downloads. Downloads. Oh. Okay, this was a lot easier on the Ubuntu. I need to know the exact file name of that. And yeah, I would really like to load it up. I'm going to pause. Okay, I just paused to grab that file name. Hopefully that's it. Downloads, it looks like it. So, strangely with the Arduino, when it's loading a library, it doesn't necessarily, this is still the, that looks better. Library, okay. I'm not going to do that. I'm just going to go see in the examples. There, W3, you see I renamed it. If I had left it with the project with the old name, I wouldn't know if this was the new one or the old one, but now I can tell that is the new project. So there we are. By the way, that include file I mentioned is right here. So everything looks good. I'm going to get that compiling. I think I'm just going to pause. So, okay, it's looking for my port and it's uploading. By the way, this is much faster on Linux, and also Windows has one little extra thing that you have to tweak. It's about file names. But that looks like that's good. So let's check my port. I've now switched to COM24 port. And let's look at the serial monitor. So what we have here is, in 2 seconds, it's analyzing at 62%, 0.62. 62%, the Arduino is still. So let's try some of these, and I'm not guaranteeing they'll be perfect. So here we go, starting. I'm doing a W. Let's look for the W. 13%. That was pretty nasty. Let's try another one. Okay, not this one. Let's try. I'll hold it up in the air. So starting, there's my W. And, great movie, great video. Here, let's try some more. Let's try the 0. So there's a 0 and 27%. Let's try, I didn't get anything, so that's still, let's try erase. This is the new one, erase. And 63%, so that's looking a little bit better. Here's an S, and this is good, 32%. So this is good for students to get a sense of, machine learning is all numbers based, and you can make your models a little bit better. That one was weird. Let's try it again. Oh, it thought it was an O, so there we go. Now it's a D. So when our students make our application, where on this screen it actually writes out words, we need some error correcting. And that's where the erase is hopefully going to be helpful. Now, next thing is, not all your kids might have a Nano 33 BLE Sense lying around at home. And at the moment, everybody's online. So what can we do with Edge Impulse to help solve that? Let me just see if I can connect up again. Once again, we're always going to this part. There was something that said live classification. So live classification, it looks like I'm connected again. And 3 seconds, accelerometer, that. So we're going to start sampling. Now, I can do this. You can't see it on the screen, but, oops, kind of messed that up. Down below, I think, oh, there. I could switch to classification mode, but I just kind of want to work here because there's more information. I'm going to have to find my page up and page down buttons. So remember, I have to turn it this way, and it's too bad my camera's where it is. But let's just try this. I'm going to live classify. I'm going to watch the screen waiting to start and sampling. So there was the W, and this one, once again, is live classifying. And let's go page down. Oops, page down. There we go. So this time it read it as an O, but there's what the actual one, and that's the one we're trying to classify. So it was over there with the W's, but it just kind of got it as something else. So there is a lot more information, and it gives you the raw data right there. So let's try another one. Let's try the erase, the new one I've just done. So start sampling. Let me just think this through. Yeah, so start sampling, wait for it, sampling, and that's all I did for erase. And now we can page down. And still erase. So it got the erase, good. Let's just try some other ones. Let's try an O. Waiting, starting. There we go. And page down. And this is pretty much going to be it. Where's my values? I got the D at 57%. There's my O. So we've either got some work to do with our library, or when we write our code, we've got some work to do. And as I said, and this could be just because I'm trying to do a video of it, the confusion matrix is looking a little bit better, but definitely some of the letters, like O, didn't have good accuracy, whereas D. So things to work on, but this is the example. I'd love to show you a video of the final product. Theoretically, we should be able to hold the Nano and do some kind of writing of words. Yeah, have a good day.